Good afternoon. Welcome everyone to the presentation for the Masters in Software Engineering for Saxion. My name is Ivo van Heurne. I'm one of the lecturers in the Masters program, and I'm going to give you a quick overview of the content of the Master and the career opportunities and the way that it's structured. What is this about? The ICT Software Engineering Masters at Saxion is a one-year program for software engineering specialists. So that means that we are not going to teach you how to program. That's something that you can learn in the bachelor's program or in the associate degree program. We're assuming that you already know how to make software and that you want to learn how to make more advanced software, more reliable software, more innovative software, and that's what this program is about. It's about tackling more complex problems. And the end result is that you will, upon completion of the program, of course, receive a Master's of Science degree. In the educational system in the Netherlands has a distinction between a research master's and applied sciences master's. And a research master's is theory-based, so it's really focused on preparing you to become a scientist, to do academic research. That means that you often need to do a so-called pre-master's course because it's very theory heavy. You need to have a lot of mathematical knowledge as well, and that's not something that everyone already has. So in the Netherlands, at least, that would take you about 2.5 years to complete. An applied sciences master's or an applied master's, that's a master's that is based on design instead of theory. So we're trying to solve real world problems that companies are having right now or might be having in the future. And that means that we use advanced knowledge and theory, but we always start from a real world problem. For our course, at least, that means that you don't need a pre-master's and that you will be finished if you do everything in the time that a regular student takes, then you would take 1 year to complete this course. So our program is project-based, so that means that all courses in the program are actually a project. So we don't really have written exams. You apply the knowledge by building a software product and by applying the techniques and the methods that you learn. These projects are either projects inside an actual company or based on problems that companies have experienced in the past. Of course, you won't be on your own for this, so there are weekly coaching sessions by experienced practitioners from industry, also weekly lectures for learning new stuff, gaining new skills, and you can expect to be at university about 2 days a week, and the rest of the week, because it's a full-time program, the rest of the week you will work on your project together with your team, or you will be doing self-study in preparation for the workshops. So this is a rough overview of the curriculum. So we have 3 projects. The first project is a software engineering project, so it's about general software engineering knowledge, which I will explain a bit more about in a minute. And the second project is a 10-week specialization project, and this is kind of an elective. I'll also explain a little bit more about that in a minute. And then at the end of the year, you're doing a graduation assignment inside a company and you're solving a real world problem there. So the first project, the software engineering project, we focus on 3 themes. So first of all, learning methods and tools to build more robust and reliable software. Of course, everyone can develop some not that great software in a few weeks. Now with all the vibe coding going on, maybe even in a few days. But of course, that's not software that is reliable. And you cannot really give any quality guarantees about this software. So this is not something that you would want to use under in high stakes environments or in a company for like the next 20 years. Second theme that we focus on is distributed systems. So things are quite easy to understand if you keep everything on one machine. But if your system is distributed over maybe hundreds of machines, you need to design the system in a totally different way, and there are totally different problems that you will experience. And the last theme is improving your software design skills. So we're talking about new kind of programming paradigms, new kind of design methods to make sure that you actually design software that's maintainable and easy to understand. And besides that, we're also doing a bit of work on your professional skills, what we call professional leadership skills, and paying attention to how can you make sure that you can advance your career in a company, or how can you lead a team of other engineers. So that's something that we will pay attention to as well. The second project, that's an elective, and one of the things that you could choose is a data ops specialization. So this is a specialization project that's going towards a bit of the data science side. It's about data analytics, machine learning. How are you managing those kind of projects? How can you achieve trustworthy and reproducible results? And how can you integrate these systems into your software product? So you'll learn a bit about how do these systems work, and how could you build them yourself, as well as how can you use them in your own systems in a useful and reliable way. Another possibility is an open specialization. So instead of the data ops project, you could choose your own subject to specialize in. And that can be any IT subjects, as long as we can find a researcher that has actually some expertise in that subject. So in the past, we have had people doing projects regarding, for example, security or IoT or UX design. So there are a lot of different possibilities in that regard. And in this case, it's more of like an individual project where you gain new expertise and apply that then to a practical problem. The last project is a graduation project. And this is an internship that you do inside a company where you solve a problem for them. And there will be a company here in the region that we have relations with, but yeah, it can be any kind of company if you want to do it at a company of your own choosing. And you will get day-to-day mentoring from a professional engineer at that company, and of course also weekly guidance from the lecturers at the university. So what are people in industry saying about master's degrees and about this master's in particular? So for example, René van Hees, who's a chief software architect at Thales, he said, well, if you do a master's like this, you can fast track to all kinds of senior level positions, because you're thinking at a more abstract level, you have more analytical skills, and those master's graduates, they are able to find the actual needs behind a request of someone, and to take the broader overview and deliver what's actually necessary instead of what someone is asking. Another example, Kirsten den Hollander, lead learning and development at Topicus, which is a big IT company in the Netherlands. She said, well, like At their company, engineers can grow towards, for example, becoming like more of a tech lead and more of a management role, or becoming the software architect or like a technical expert. And what they see is that if you have a master's degree, that accelerates your growth in one of these directions, because you have more expertise, you have a broader outlook, and you have a more investigative way of thinking. So what could be possible career directions? Well, you could think about maybe like a system architect, someone who coordinates the technical vision for a system, who makes like broad technical decisions, coordinates between teams, makes sure that the quality is built into the system, and that there's a certain guarantee about the reliability and other qualities of the system. Another direction could be a product owner, where you are basically the CEO of a software project. You're coordinating with higher management, you're coordinating with the teams, you're coordinating with the customers. And depending on what kind of specialization you choose, you could also go more into the direction of DevOps and cloud development, or something like machine learning engineering, data engineering. So what are the admission requirements for this program? Well, you need a bachelor's degree in software engineering or a closely related field like computer science or software development, computer engineering. You need sufficient knowledge of English. So in our case, that's IELTS 6 or equivalent. You can find more details about this on the Saxion website, as well as like the equivalent scores for other kind of tests. So we will do an admission interview once you apply with every applicant to talk about like what are your experiences with software development, what are your goals in pursuing this program, and based on that we will either admit you or advise you to go and do another program. So good to know the application deadlines for the program. For EU citizens, that is at 15th of August. I see here that says 2025, but that should be 2026, of course. And for other countries, it is either 15th of March 2026 or 1st of June 2026, and that depends on your country of origin, and you can find more information about that at the Saxion website. So if you have any questions, if you need more information, please have a look at our websites, saxion.nl/MICT. And you can always contact us. There is an email address listed on there that you can use to get into contact with us, and we will be happy to answer any questions that you have. So thanks for listening, and hope to see you next year at Saxion in Deventer.